In last video, we had discussed about the condition for simple harmonic motion. In this video, we are going to solve a question related to simple harmonic motion and free fall. I was thinking about a topic which has both of these two situations, free fall and simple harmonic motion. So suddenly, thought came in my mind related to bungee jumping. So guys, you may have experienced bungee jumping, and I have also experienced bungee jumping. In case of bungee jumping, in the beginning, when there is a slack in the rope, we are in free fall. And once the rope is fully elongated and not expanded, I'm saying fully elongated, then you will find that the rope starts applying force on our body and we come to rest after elongating the rope for a few meters. And once we come to rest, we start oscillating up and down. And that is a very good situation of simple harmonic motion. So there are three questions which I have created for you guys. So the first question is, the person at rest jumps from the platform. Calculate the velocity of the person when the bungee cord will have been extended to its full length without any elongation. Okay. The length of cord is 80 meter. So here, let me draw this diagram. This is the 80 meter length. 80 meter. There is no elongation. So if you read this question carefully, you will quickly come to the conclusion which formula we should apply here. So any thought which formula we can apply here? Because the object or the person who is jumping is initially at rest. It means initial velocity is 0. S is given to us. It means distance traveled by the person during this free fall. Free fall would be 80 meter. And the person is falling near to the surface of the earth. So we can take G is equal to 9.8 meters per second square. So have you decided which formula you are going to use? We can use here Suvat equation. And there are three Suvat equations and I'm going to use the third one. V square minus U square is equal to 2AS. A is acceleration here, and instead of using A, we can use G. So our formula becomes 2GS is equal to U square minus, here I'm just writing opposite in opposite direction. So it's a V square minus U square is equal to 2GS. And as we know, the person jumps from the rest, so U also becomes 0. So finally we can write V is equal to under root 2GS and V is equal to under root 2 into 9.8 into the length of the cord or the rope. So it's a 80, and if you do the calculation, you will get let me do the calculation here, and we can do 2 into 9.8 into 80. So we are getting 1568, and let's take root of that. We will get 39.59. So 1.68 and 31.568, and that will give you V is equal to 39.59 meter second power minus 1. Now one more thing we need to consider here. Our data has only two significant figures in case of acceleration due to gravity and one significant figure in case of this height. So our final data should have, our final answer should have only one significant figure. We can write this, but this quantity has four significant figures. So let's round it off and we can write it as 40 meter second power minus 1. So the velocity of person at the mean position is 40 meter per second, and mean position here means that the cord or the rope is fully elongated, right? Now let's go to the next question, and the next question is the maximum extension in the length of cord when person comes to rest at B. And this was the mean position, and when the person is falling, the person will not come to rest immediately at A. He will continue to fall, but the rope will apply tension upward, right? And when the rope will apply tension upward, slowly the person will come to rest. And during that time, the person, the length of the rope has elongated by 20 meter. 20 meter. And we need to calculate the elastic constant of the cord. Why we are calculating elastic constant? Because it's acting as a spring or a rubber band. Yeah. So if you try to imagine the situation, then two things are happening here. One is person is falling by 20 meters further from point A and reaching to point B. So the person is losing potential energy during this period. So loss of PE. And since the person has jumped from this platform and has gained certain velocity, which we have calculated here. At point A, the velocity of person is 40 meter per second. So the person is having kinetic energy at point A. So to calculate the elastic constant, what we can do is we can use the law of conservation of energy. So energy at A will convert into energy at B. So energy at A is, first of all, the kinetic energy 1 by 2 mv square, as well as the potential energy which the person has because of the height, which is 20 meter. So mgh is equal to, all the energy will get converted into the elastic potential energy of the rope. So here 1 by 2 kx square. Now substitute the values, and the mass of the person is given to you, it's 70 kg. So 1 by 2 into 70 into v square plus 70 into 9.8 into 20 is equal to 1 by 2 k into x is 20 square here. So if we solve it, and we can substitute this value in the calculator, and here I have not substituted one more value, which is the value of velocity, and the velocity is roughly, we can take 40, which we have rounded off, so we can take it as a 40 square. So let me do it by using the calculator, and you can I will pause the video for some time. Now if you use the calculator, you can find the value of elastic constant K is equal to 348.6 Newton per meter. You can round it off to 350 Newton meter per minus 1. Now let's go to the next question, and the next question is, using the data in 1b, calculate time taken by person to return to mean position A after coming to rest at B. So as we have already discussed, the person will start oscillating and this rope is elastic. So the person will go back and forth like this. So as the person comes to rest at the maximum elongation of the rope, here the final velocity becomes 0, and now person starts returning back here. So we have to find time taken to return back to position A from rest, and to do that we can use the formula of time period. And you know the time formula for spring mass system. This situation is exactly same as the spring mass system. So T is equal to 2 pi under root m by k. Here k is the elastic constant or the spring constant. So we can write T is equal to 2 pi under root, mass of the person is 70 kg, and spring constant just now we found that is 350 meter, 350 Newton meter. So T is equal to 2 pi under root 70 by K, and K is 350. Now I can here only cut this 0 and 0, and 7 5s are 35. Oh, great. So we will get T is equal to 2 pi under root 0.20, I think. Yes. Now if you take the root and multiply with 2 pi, we will get T is equal to 2.80 second. This is the time for one complete oscillation. It means the person will go here, come back, and then reach back to point B. But if we are calculating just time taken by person to reach from B to A, so it's a quarter of the cycle. This time is just T by 4. In that situation, we can write T is equal to T by 4, which is 2.80 or 0.70 second. So this is all the solution of these three questions. You can go back to the questions, or you can pause the video in between also. This is question number 1. The velocity of person we had got 39.50 meter per second. And in question number 1b, we had got the spring constant 350 Newton meter. And in question 1c, we got the time taken to come from B to A, which is quarter of the time period, is equal to 0.70 second.